In this unit, 6.3, we're going to talk about the inverse normal. Now, the inverse normal is going to solve this problem for us. Suppose this is like a backwards problem from what we just did. Given an area under a normal curve, find the x-score that produces it or that corresponds to it. So in the last thing that we did, in the last section that we did, we were given an x value and then like a range, an interval, and we found the area, found the probability. But now we're going backwards. Given that probability or given an area, find the x's that produce it. So here's a picture of our problem. So we're given a normal curve, and just as an example, suppose the mean is 130. And there's a value here, and the area above, the area of this interval right here, the area of that above that interval and under the curve is 0.38. So 38% of the population is in this interval right here. So what x value is that? So I'm asking this question. X is what value? Now, there's a way to do this with tables. The book shows it. Let's not do that. Let's just go direct to the calculator. Here's how we're going to do it. Kind of getting used to this now. We're going to press second vars because we're looking for probability distributions, and that's where the distributions are. Second vars. Now you're going to go down to number 3. Look at number 3. It says inverse norm. It's all in lowercase letters. It looks like except that N. So it says inverse, and then it's got a capital N for norm. All right, so it's the inverse normal distribution. That's the one you want. So select number 3. Press enter. Scroll down and press enter, or type in the numerical key 3, and you'll get inverse normal. Now, what pops up on your screen, I'll do it at the top right here, is at the top, we're used to seeing this, tells you which distribution you're using, and then asks for this. What is the area? Now, the area is always going to go like this. The area always starts from the very left and goes up to that value right there, just like it is in our particular picture. All right, that's how it always goes. So you're going to put the area from negative infinity up to this point. Now, what is our area? Our area is 0.38, all right? So we're going to type 0.38. So mu, we know that that's 130, and sigma, oh, I did not give a sigma in this problem, so let's make one up here. Let's say that the sigma is 18. All right, so in this curve, the mean is 130 with a standard deviation of 18 units. So go down to paste, and then you'll select paste, press enter, press enter. And when I press enter, I get the inverse norm, although I can only see the RM. The area is 0.38, the mean is 130, the standard deviation is 18, and now you press enter again to actually make it compute. So let's do that. And I got this. I got 124.50, say. So I'm going to draw a picture of what's happening. This will be x's. There's our p of x's. Our high point is 130, and we're saying that 38% of the area comes up to this number right here. Right, so that was our problem right back here. What was x? So we just did an inverse of the normal, and we came out to this number here, 124.5. Right, now we're going to have to round off here. Now, if I do normal rounding, I would round to 24, or normal rounding, you round up, right, to a 5, 125. But if I round up to 125, I'm going to be up, right? I'd be actually over here. So I'd be getting more area. So in these problems, you always round down, all right? You always round down. Now, these problems are typically like guarantee problems. So these problems, when you use the inverse norm, you're probably doing something with the guarantee. And if you always want to round it down, so you're not going to guarantee something for more than you have to. All right, so we're always going to round down. If I round up, remember, now if I round up, I've got more area. So always round down. That means you're always, say, going to be less than that area right there. Let's do an example problem. I think it's number 38. Here's how it goes. The amount of money spent weekly on cleaning, maintenance, and repairs at a large restaurant. So how much they spend weekly on cleaning, maintenance, and repairs was observed over a long period of time and was found to be approximately normally distributed with a mean of, okay, I'm going to write this down. Write it up here on the right. The mean cost, weekly cost, is $615 with a standard deviation of 42. Now, it's also, we're given that it's normal, all right? So as soon as it's normal, I can draw that normal curve. The mean is 615, standard deviation of 42. Now here's part A. Part A says 646 is budgeted for next week. What's the probability that the actual cost will exceed the 646? So what we want to know is this. We want to know that the cost exceeds 646. Now I write it in English because that's just me. It just helps me when I write in English. I get a feel for what it is I'm doing here. So now I'll put it in terms of x's. Exceeds 646. All right, so I'm going to draw a curve that corresponds to that. I'm in x's. I'm not going to convert to z. I'm not going to use the table. Here's the normal curve. Now what was the mean? 615. And we're over here at 646. Now 646 is up here, right? It's bigger than 615. So 646 is here. And we want to know what's the probability that the cost will exceed. So what's the probability that we land with a number bigger than 646, some number out there. So we're measuring that area right there. That's what it is that we're looking for, okay? That's whatever this is here, that's what that area is. Calculator. Oh, let me get a different color here. There we go. Calculator. Second, there's, it's got distribution on it, right? I'm going to pick number 2, right? Normal CDF, right? So when you pick number 2, it's asking for what is the lower bound, all right? Now the lower bound is 646. What's the upper? Well, the upper, that is going to be, remember, that's going to be, it just keeps going. It just keeps going out here, so that's infinity. E99. Remember how to get it? It's second, and then right above the comma, which is by the 7, you'll see E. All right? So you get E99, and that's just like 10 to the 99th. 1 followed by 99 zeros. All right, so let me get that in my machine. And then it wants mu. Now the mean here is 615. Sigma, the standard deviation, is 42. And we'll paste. And when we paste, I'm getting this. I better do it up here. I can't see any of this, but it says normal CDF. It says 646, E99, 615 is the mean, 42 is the standard deviation. We're going to press enter to make it compute. And when I press enter, I'm getting this. I'm getting 0.2302228 ... I'm going to round off to 4 places. That's a 2, so I'll just round off here. So I'm going to say 0.2302. So for part A, I'm going to claim that the probability that x is greater than 646 is 0.2302. Or that's going to happen, right? We're going to exceed our budgeted amount about 23% of the time. Now here's part B. This is the inverse normal, all right? So how much should be budgeted for weekly repairs, cleaning, and so on, so that the probability that the budget amount will be exceeded in a given week is only 10%. All right, let's draw this. All right, here's x, here's p of x, and we have a normal curve. And the mean here is 615. Now, where do we put this? We've got 10%. look at this. We want, what x value do we want to put in here so that we will exceed it in a given week is only 10%. All right, now if I put it here, if you're wondering where to put things, start here. What's the probability of exceeding 615? Well, that's 50%, right? Exceed, you go to the right. So the probability of exceeding it is 50%. So I think I'm going to put it over here to the right, right? If I put it to the left, I've got this much, I've got all of this, over 50%. At 615 is 50%, so put it here. All right, so our x value is going to go here, and that's what we're asking. What is that x? So that these values out here, this is 0.10. Okay, so inverse normal. We're given an area. Find the x that corresponds to it. So, second, VARS. I think you probably have this by now. That's where distribution is, right? And select number 3, which is inverse, and then a capital N for norm. All right, now when you do that, you get area. Now we have to be careful because the area the calculator computes is this area here. That's just the way the calculator is programmed. The calculator is programmed to go from negative infinity up to your number. So if this is 10%, this has to be what? That has to be 90%, right? That's going to be 1 minus our 10% because we have to convert it to the side that we want. All right, now it's also asking for mu. Now mu is 615, right? That's the average amount. The standard deviation is $42, so that means just our deviations are about $42 a week from that 615. And now paste. All right, and when you paste, it looks like this, right? You get inverse norm, although you can't see it. And it's going to be 0.9, right? Because 90% of the area is to the right, or to the left. And then the mean is 615. The standard deviation is 42. Press enter. And I'm coming up with this. I'll do it up here. I'm getting 668.825 ... Now, what do we do with this? I'm going to put that number right here. So the question is, how do we round? All right, so in the last problem we did, we were doing a guarantee type problem, and we always rounded down. What are we going to do here? Well, now we don't want to go over the amount, right? So what if we rounded down to 668? If we rounded down to 668, right? If I take this number and round it down to 668, I'm getting more area. So I'm going to exceed more. So I'm going to round up to 669. That will give me less area, so albeit maybe like less than 10%. All right, so what I'm going to do is I'm going to round up. So I'm going to write this now as 669. All right, so how much should we budget? $669. We'll have a less than 10% chance of going over. So let's just talk for a minute and finish this off with rounding. When you're doing guarantee problems, you're always going to guarantee something below the mean, right? You're not going to guarantee it so you have to replace over half of something. You're going to guarantee it some value down here below the mean. All right, so whatever it is, you want to round down. That's the probability of having to replace something, right? So you always round down. So I'm gonna say this: if x is to the left of mu, that's a mu, round down. Then, if you're doing something like what we just did, you want to be in the top 10% of your class or something. You want the top 10%. Now you're up here. So what are you going to do now? Well, now you want to be within the top 10%. So now you're going to be rounding up. All right. So if x is to the right of mu, round up.